Twitch session. My name is Luke Hoban, part of the founding team at Pulumi. And I'm going to spend the next 45 minutes or so just kind of giving folks an introduction to Pulumi, showing off some demos, just kind of playing around with some code, showing kind of all the fun things Pulumi is capable of. Thanks for joining us. I think this is our first attempt at a Twitch stream. I think we're going to plan to do more of these in the future, but definitely give us feedback about what you like and don't like and want to see more of, and we'll make sure to incorporate those in the future. So first I wanted to give a quick kind of introduction to what Pulumi is all about, and then I'll jump into code and spend most of the time just kind of playing around in code to give you a feel for what the offering actually looks like. So Pulumi is a way to get code and infrastructure into the cloud faster and collaboratively. And so our goal is to make it really easy to take advantage of all of the amazing technology that's available in sort of the modern cloud, whether that's containers or serverless or managed services in the cloud provider. Take all of that good stuff and really take advantage of it as an application developer or as a DevOps engineer. We find that the cloud platforms today have incredible capabilities, just tons and tons of new features that they're delivering. But in general, those features tend to be fairly cumbersome to actually take advantage of. You have to stitch a lot of different things together. You have to write some complicated YAML or JSON files to describe all the different resources you need. And especially for application developers who are needing to integrate these at a faster and faster pace, it's a lot of work there, and we want to make that really easy to use. So I'll start by just kind of giving a really quick 0 to 60, going from nothing to having a running Pulumi program, and then I'll kind of step back and show a bit of what's really going on under the hood. One thing I should note, Pulumi is in private beta right now, so for folks who are interested in kind of playing around with Pulumi, definitely just drop us a note, go to pulumi.com, sign up, and we'll get you into the beta. We're going to be opening up more broadly in just a little bit here. But for now, if you do join the beta, you can come to docs.pulumi.com, come to the landing page, just go ahead and download Pulumi, and then you can get started and follow along with some of the demos I'm about to do. Okay, so let me just jump over here into command prompt, and I'll create a folder for our Twitch demo, and then I'll just type Pulumi new to go and create a new Pulumi project. Now Pulumi lets you use kind of a variety of different programming languages to author your cloud applications. And here we're going to go ahead and use the hello AWS JavaScript, which uses JavaScript to define our project. I'll pick Twitch demo, no description. I'm going to use Twitch demo dev, and just because I'm over here in Seattle, I'm going to pick US West 2. We'll go ahead and get the dependencies we need for this node program. And then let me just show you what this looks like. So because we're using programming languages like JavaScript, in this case, we can show that to you inside a developer tool. Here I'm using Visual Studio Code. We can see this simple kind of program shows off a few kind of simple things you can do at a high level using Pulumi. So here we're creating a HTTP endpoint. This is just a public HTTP endpoint that we want to expose to the internet. And then we're going to host some static content from this www folder. So as you can see here, we have an index.html and a favicon there. And we're going to host a REST API route. So this /source route will run some code when we invoke it. And then we're going to publish that and get back the URL. So I'll get into kind of what's really going on with this code in a second, but let me show you the full end-to-end kind of experience here first. So I can type Pulumi update in this folder, and that will go ahead and tell me what kind of infrastructure Pulumi thinks it needs to create to deliver the application that I wrote in that JavaScript program. And so that JavaScript program turned into the following 17 resources that we want to create. In this case, we're targeting AWS, so we're going to create an AWS S3 bucket to host that static content. We're going to create an AWS Lambda function to host that REST API callback that we had. And we're going to create an AWS API Gateway REST API to host the public-facing HTTP endpoint. And then the rest of this is just sort of the various things I have to do in AWS to stitch those pieces together, the permissions, the roles, what have you. But we've hidden all those implementation details away behind these simple abstractions in this case. And so you saw there I got a preview of what was going to be created. I got to decide whether I wanted to do that or not, and then when I said yes, we're now going to go ahead and actually create all those resources in the cloud provider. And so here we're going, and we can see how these resources are getting created in AWS. And it should take just about a minute or so to create all of these, and then we'll dive into what we created. One quick thing to notice here, there's a few interesting things about this code. One is we didn't have to reference all of those individual pieces, all the individual AWS Lambda function, the individual AWS S3 bucket. We were able to use just higher level kind of frameworks, and this is a key thing we'll see repeatedly kind of with Pulumi is we provide access to some raw building blocks, but then we let people build various components that create new abstractions, new capabilities that are made out of lots of those different cloud capabilities. And so here, this HTTP endpoint is something I can program against. It will, under the hood, create some other AWS resources, but from a developer perspective, I can stay with this very simple output. So I'm just going to quickly take a look at what the outputs were from that stack. Just going back here really quick, you see I did exports.url equals, and so now I have an output property called URL. And then I can go and hit this endpoint here, and you see this, bump up the font a little bit. This just returns some basic HTML, and it says served from AWS. And if we just go back to our code, we see that AWS is coming from this REST API call, and the rest of that content is coming from this simple index.html. So there we go. We were just in, with a very small amount of code, able to deploy a sort of full working serverless application that hosts some static content and hosts a REST API. So I'll go a lot more into the details of how this particular example works in a second. There's two more things I want to quickly kind of highlight here. So one, you see we've got this permalink here. So when I deploy things using Pulumi, as well as going and deploying some resources into your target cloud provider, in this case AWS, we're also going to keep track of the resources you created in the Pulumi backend service. And this ensures that after you do multiple deployments, you can see what the state of the deployment is after each one of those. And then we can track how your cloud infrastructure has evolved, and you can see that history over time. And so here you can see, I can see the full details of what resources were created. But even more interestingly, I can see all of the resources that make up my application. And so for example, if I look at my function here, I can see my Lambda function. Open that up in the AWS console. And if I go to monitoring, for example, we see we have one hit against that Lambda. And so when I went to that web page earlier, that caused that to get invoked. But we can see we can go and deep dive into the underlying AWS resources from within here. I'll show some more of this a little bit later as well. Okay, so that was a quick high-level view. In that example, I showed off using JavaScript, using AWS, and using a high-level framework for HTTP endpoints. As we'll see through some of the other examples today, you can use Pulumi with a variety of different cloud providers. We can support AWS, we support Azure, GCP, and even targeting Kubernetes directly in any cloud or on-prem. And then you can also use a variety of different languages. So we support JavaScript and then TypeScript as well. We also support Python today, and we're expecting to add additional languages in the future. I'm going to focus mostly on JavaScript and TypeScript today, and I'll start with some demos on AWS, but if folks are interested in demos on any of the other pieces here, we'll definitely dive into those as well. Okay, so let me kind of start, that was kind of a high-level thing. Let me start down at the sort of the base level of working with AWS and show kind of how some of this stuff works. So here I'm going to show an example of just a simple kind of infrastructure demo. So just deploying some basic AWS infrastructure. In this case, that's going to be an EC2 security group and an EC2 instance. And so this is the kind of code, if you've ever done sort of raw AWS infrastructure, this is the kind of thing that you'd be familiar with from your CloudFormation experience, for example. The key difference here is that we're doing this in JavaScript. And in fact, in this example, we're doing it in TypeScript. That has a few benefits. One, we obviously get simple things like if I mistype the name of my instance size, I get a squiggly and I get told that there's an error. I can get things like IntelliSense. I can see the full list of APIs. This sort of things are actually pretty amazing. There's something like 500 APIs available in this AWS library that we project here. And getting IntelliSense, getting completion lists, getting error checking against those is a really nice way to be able to explore and understand and rationalize the amazing surface area that these cloud providers have without having to just sort of guess the right strings and copy paste from documentation. So in this example, we're just creating these two resources, the security group and this instance, and then we're going to go ahead and export the public IP address from that. And so let me just show you kind of what happens when I run this example. Let me just see what stack I have. So Pulumi has a notion of stacks. So I can take my program that I've written here, and I can deploy any number of instances of this program, and each one of them is sort of isolated from the others. So for example, I could have one instance which is my production environment, one instance which is my dev environment. In a team setting, each one of my developers could have their own instance of this program running as their own development stack. And so I can create one of these stacks. I guess right now I have a little Twitch stack that I've created, so I'll just go ahead and use that. I can set config on that stack, and so I've set the AWS region to be US West 2 for this stack. And then I can go ahead and run Pulumi update. You'll see that I had 0 resources in this stack currently, so I hadn't deployed it yet. When I do go and try and deploy it, we will see it creating a couple of resources. So you see it deploying exactly the 2 resources I asked for, the EC2 security group and the EC2 instance. You see also there's this Pulumi stack, which is just a parent for all of the resources that are part of the stack. So you'll see that in any stack that you create with Pulumi. So I'll go ahead and do that. It'll just take a couple seconds to spin up that EC2 instance. One of the key things here is that this Pulumi AWS library projects the entire surface area of AWS. So every API that's available in AWS, and we already are revving this frequently to take inputs from new APIs that have been delivered in AWS. And so we can use anything that's available in AWS, and the API for using it is sort of the basic API that you'd expect, looking at these resources. So here you can see all the different properties that are available on a EC2 instance, for example. And so at this level, you can work with any of the raw infrastructure here from AWS, but also from Azure or GCP or Kubernetes. And so Pulumi gives you access to all of the resources that are available in those platforms. I've now created this, and I can sort of say Pulumi stack output and see that I have now a public IP address and public DNS. And similar to before, if I click on this permalink and come into my resources and click on this AWS instance, we'll see that I can get directly into my EC2 instance and see that it's running in AWS and still initializing right now, but the instance has been created and is running. And so I was able to just write that bit of code and declare that and run it now in AWS. Now, one thing that's really important kind of to point out about Pulumi is even though you're using JavaScript to describe this, this is still sort of immutable infrastructure. This is a declarative form of describing my infrastructure. So what my program here is describing is the state that I want my application to be in. And so what I'm saying is I want my application to have a security group with these parameters and an instance with these parameters. And if I change one of those, so like let's say I want to cut off SSH access to this, and I come back over here, because I'm using TypeScript, I'll just build that real quick, and then I do Pulumi update. What we'll see is that this, instead of recreating all of my infrastructure for this application, Pulumi is going to compute the minimal diff it needs to provide to make the change to my target infrastructure. And so in this case, I can just go and do an update in place to my security group to change my ingress rules. And I can even see the details and see that the change I'm going to make is to remove that mapping for port 22. And so if I go ahead and say yes, I'll make that change. And notice I don't have to update my EC2 instance. So this was really quick. It completed in about 3 seconds there. And in fact, if I go just back into this console and look at my security group in AWS, we can see that now this doesn't have access to port 22 anymore. So we made that change in our target infrastructure immediately. And so the key thing here is that with Pulumi programs, you're using JavaScript to describe the desired state of your application. And so then when you're iterating on your application, you can make local changes, and those will have only the targeted impact they need to on your cloud infrastructure. And so in a sense, a Pulumi program, once it's deployed, runs forever until you decide to tear that piece of infrastructure down. And every time you do a Pulumi update, we're patching in the changes that you've asked for in your program. And that's part of why we give you that preview, is so that you can see what are the changes that Pulumi is going to make to your infrastructure, and do you want to make sure that those are the right changes that you expect, and that you're prepared for any updates those are going to make to your infrastructure. So as a quick kind of view of what kind of Pulumi can do at the very lowest level, and we can make a variety of different changes here. One of the things that's most kind of interesting in terms of taking advantage of JavaScript, though, is, let me open this up. Let's see if I have one open here. Okay. Let me go over to another example that's kind of related to this. So when we have a programming language like JavaScript, as well as just constructing the raw objects from AWS, we can use all the other features of a programming language. So we can write for loops, we can write if statements, we can write arbitrary code and use node packages to do whatever logic we want. And this lets us sort of mix in a whole bunch of interesting capabilities into our infrastructure programs. But the most interesting thing really that programming languages give you is the ability to create new abstractions and new components. And so I'll start with a very simple example of that, and then we'll show some of the really interesting kinds of components that we've been building with Pulumi, and that others in the private beta have been building and using as well. So in this example, instead of me directly constructing my EC2 instance and security group, I'm going to instead construct a webserver.micro and a webserver.nano. And this you can imagine, instead of me just copy-pasting a whole bunch of CloudFormation around or whatever else I might have done to describe my infrastructure, I might instead want to just use something that my team had built, or just abstract away and give a name to a common pattern that I want for this subset of infrastructure. And if I go to definition on this micro web server instance, we can see kind of how we implemented this component. And so you see a couple things. One, it's really kind of the same thing we had in our previous example. We have an EC2 instance here, and we have that security group as well. But there's two differences. One is that this security group is just a module variable in JavaScript, and so this is encapsulated within this module and not exposed out to the rest of the world. So this is sort of showing off kind of the benefits of encapsulation that we get within traditional programming languages. And then I've created a new class called server, which sort of gives a name to this pattern of constructing this kind of shape of EC2 instance with a shared backing security group. And so instead of me exposing all the different parameters that are available to an EC2 instance, I can just expose a couple of simple parameters that I want for within my organization to parameterize my server by. So in this case, we'll just give it a name, and we'll give it a size. And in fact, then we can create some base classes, and of course these are a little silly just as examples, but you can probably imagine how a similar sort of abstraction might make sense inside your infrastructure deployments, where you have a certain shape that you use typically, and so here you have create a micro instance which just bakes in t2.micro. So the key at the end of this is, if I go back to that index.ts, that now my development team can sort of write code like this, and my core infrastructure team can manage those components. Taking that a step further, because this is all JavaScript and we have access to kind of NPM, or in Python we have access to PyPy, we can go and share those components with others in the community or with others inside our organization. And so we can build and share and reuse components that describe cloud infrastructure through the popular package managers. And so we'll see a bunch of examples of some of the packages that we at Pulumi have built as examples of this. Okay, so that's a quick sort of view of kind of the beginnings of what we can do in terms of building our reusable abstractions. Let me go back up and show, well, let me actually show one that's one step kind of up from this. Let me see if I've got it open here. No, I did. Okay. Okay, so let me show you another library we have called Pulumi AWS Infra. And so let me show you a couple of things. One is that this is all JavaScript, and we have access to kind of NPM or in Python we have access to PyPy. We can go and share those components with others inside our organization. And so we can build and share and reuse components that describe cloud infrastructure through the popular package managers. And so we'll see a bunch of examples of some of the packages that we have built as examples of this. And so, when we see folks doing infrastructure programming in AWS, for example, one of the patterns we see frequently is people copy pasting tons and tons of boilerplate to create simple AWS network infrastructure or AWS ECS instances to run all of their compute. And so in this example, let me just show real quick. We have in AWS Infra package, we have some abstractions which let you sort of immediately create a baseline sort of AWS network infrastructure. And so here, AWS Infra.network is a component we've built which lets you just specify how many availability zones you want to create subnets in, whether or not you want private subnets associated with those, anything you want in terms of sort of the core patterns for describing an AWS network. And then you can easily go and use this, just write new AWS Infra.network. You don't have to worry about all the little details of that 90% of the time you're not worried about. If you do need to tweak some additional setting, you can go and tweak that either by adding that capability as a parameter on network, or by going and rolling that and using some of the underlying pieces of Pulumi AWS directly. But this gives you a really easy way to get started to build a network. And so we have a few of these kind of building blocks in this library. But let me go back to sort of something more like kind of the first example I showed, where we do sort of a bit more high level, a bit more kind of application developer sort of things. And all of that is really built on top of the same foundation of composing together AWS resources and other cloud resources. So let me go into our examples folder. And actually, let me just quickly show this on GitHub. So I'll just bump up the font a little bit. So we have an examples folder, so folks who join the private beta will have access to the examples folder, and we're going to open this up more broadly soon. Here there's a bunch of examples of how to do a number of different things with Pulumi. And the one I want to start by showing off is this Pulumi Cloud.js HTTP endpoint. So let me just open that up here. Okay, so this is an example that's a little bit like that first example we showed, where we're using a HTTP endpoint to expose a public API. And as we talked about back then, this is really just a wrapper over creating. This is really a component that we've defined in this Pulumi Cloud AWS package, which builds together a bunch of things to make it really easy to deploy serverless APIs. So if you've used tools like Serverless Framework or things like that, you can think of this as being sort of similar to what some of those tools enable, except it composes with all the other sort of AWS primitives you might want to use, or Azure or Kubernetes primitives. And so you get the sort of same ability to define really simple serverless applications, but where you can peek beneath the hood and work with the AWS resources as well. And so in this example, we have this HTTP endpoint. We define a GET handler, so we're going to accept any route off of the GET handler. And then this is sort of a really interesting thing, which we showed in that first example, but I didn't go into much detail on. It's really sort of one of the kind of interesting things that you can do in Pulumi. So here you see that we actually write the code for handling this route right in line here. And so instead of me having to define a separate AWS Lambda somewhere and build a zip and put my code all in some other folder and things, for these little pieces of code that I might want to run just as part of my, my infrastructure application, we can go ahead and define that right in line if we want to. So we can still define it as a Lambda written in any language we want, but if we want to just write a little piece of code to handle this, we can write it right in line here. And so in this case, we are writing a handler that handles any of these routes and just goes and runs this code here. Oops. And so let me just come over here and look at what stacks I have. Okay, so I have this Twitch HTTP endpoint stack with no resources in it. Let me just see what config I have set. Good, so I'm deploying it into US West 2. So let me just take a look at what happens when I Pulumi update this. So there's one other quick thing that I glossed over here. This example also highlights using a cloud.table. So as well as me defining an HTTP endpoint to host this public API and a handler to host this REST route, we also want a place to store the state associated with our application. So we're going to use a cloud.table. And this table is just going to keep track of, for every route that gets requested, how many times has that route been requested. And so we're going to update that in the table every time this gets called. And one of the sort of really key things you can see here is this is an example where I'm defining both some of my sort of what you think of as your infrastructure, your DynamoDB table in this case in AWS, and your application code sort of all together. And so I can version those things if I want to add a queue in here, and then version how I write things into that queue if I want to add some buckets. I can do all of that and all of my code versions together. And so here you see I got that AWS DynamoDB table is going to get created. That AWS Lambda function that's defined by this code right here is going to get created. And I'm going to create a AWS API Gateway REST API. So let me go ahead and create that. This again will take maybe 30 seconds to a minute to deploy. And this will deploy sort of a running application that keeps track of these counts. You see again, similar to the previous example, we can publish that endpoint and then get the URL property. And this is actually an interesting thing. Many of these resources have output properties on them. And so these are properties that will be available once the resource gets created, and we want to go and take those outputs and expose them to the developer who's running this program. All right, let's give it a few seconds to complete deploying that function. All right. Oh. I've hit the limit of the number of API gateways I can have in this account. So let me actually show off doing Pulumi destroy. So I'm going to go back to that example I deployed earlier. I'll just type Pulumi destroy. So Pulumi destroy is what I want. Like I mentioned earlier, when we run one of these Pulumi applications, it's sort of going to run forever. And when I do Pulumi update, that's going to patch in the new changes I want to make. But if I do Pulumi destroy, that's going to tear down all the resources associated with the application so that I don't have those in AWS anymore or in my cloud provider. So here I'm tearing down all those resources. In part, I'm tearing those down so that I don't hit my limit of REST APIs. I think AWS has a limit of about 50 of those, and we must have been doing a lot of demos recently. So I've torn that down now. Took 11 seconds to do that. And in fact, I'm just going to go ahead and do Pulumi stack rm to delete the stack. Okay, so now if I come over here, one interesting thing, this actually gives a chance to show off kind of another capability here. You see that during this deployment, we created a lot of the resources, but then we failed kind of 3/4 of the way through when we were creating this REST API. So you see after the REST API, we still need to deploy these additional resources, but we failed partway through. What's nice is that when I do Pulumi update, because we had already created all those initial resources, we won't have to create those again. And so you'll see that there are no changes to these components, but then we still need to create these 4. And so this is sort of when you're iteratively developing, sometimes you will legitimately hit these kinds of errors where you try and describe some infrastructure that isn't you can't create that in AWS, or there's some constraints that you haven't applied correctly. And so you'll get errors as you're kind of developing your code, just like you'd expect in any kind of programming environment. But because you're describing your desired state, you won't have to do everything from scratch. You'll just be able to iteratively move forward and fix those issues and continue with the deployment. And so this should complete reasonably quickly and just create those 4 resources. So you see now we've created that REST API because we opened up some space. And this is now available. So let me just type Pulumi stack output to see that, and we get that URL. Oh, actually, this is a little bit, this example, we want to get different routes on this thing. So let me just actually do curl Pulumi stack output endpoint, and then I'll say A. So I'll get the A route on this thing. This takes a second while Lambda warms up for the first time. Can do B, and give both of those a 1, and then we'll just do lots of hits on A. And we'll see each time we count that route up. So you see this was keeping track. This is a stateful API we've now built that has a backing data store behind it. And we're able to do that again in just a small amount of code there. And we're able to do that using real AWS resources. So this is not just a Node.js program kind of running on a single VM somewhere. This really is a managed service running in AWS Lambda, AWS API Gateway, DynamoDB. This is a robust kind of managed piece of infrastructure. But we're able to write the code for it in the same way that an application developer might write a simple Express application, for example. And so that's sort of one of the key things that we think is nice, is being able to combine the sort of real cloud infrastructure benefits of using AWS primitives and Azure primitives and Kubernetes primitives with the programming model of what people expect as sort of Node application developers or Python application developers. But here, so I hit those routes a couple times. Let me just show, we had a link up here into the AWS console. A couple of things to note. One, we can obviously see the details of that deployment, so all the details of that REST API. I can see the created date on that REST API. All the details I might want if I want to go and Spelunk in and really get details on that. I can also see the whole list of activity that's ever happened to this stack in the Pulumi console here. So you see earlier today, I guess I tried out this demo, and then just 5 minutes ago, there's that failure and then the success. If I come in here, I can then go and see, if I look at my Dynamo table, I can click on that, go to AWS. And we'll see here, I have exactly the rows I expect in my data store, and so I can go and look at my data store behind the scenes and see those details. And if I need to go and sort of look behind the scenes on any of these AWS resources that were created, I can do that through the AWS console, and Pulumi gives you really easy access to that stuff. One other kind of fun thing is the ability to do Pulumi logs. And so Pulumi logs shows me all of the logging from any of the sources of compute that are in my application. And so in this case, if I just go back to that code real quick, we'll see there's only one route. There's this handler right here, is the only piece of code. And when I look at this piece of code, you'll see it has a few console.logs, getting count, got count. And you see that those are getting printed out here. So every time we hit that route, all of the examples above, we see the logging from those. The nice thing though is Pulumi lets me aggregate those logs into one place and just type Pulumi logs. I don't have to go to each one of my different resources and see its logs inside AWS. Pulumi gives me the ability to pull out that information, see it centrally in one place. Okay, so that's a sort of a little bit more detail on how to use some of these higher level kind of serverless examples. One more thing I want to really spend some time on is kind of containers and taking advantage of managed container services as well. So let me come over to another example in here. Actually, let me just go back. I'm going to show off this thumbnailer example. So let me just open this up. Okay, so this thumbnailer example, let me just quickly show a diagram that kind of shows what this application is going to do. So this application really takes advantage of sort of all three of the things that sort of Pulumi can really help you with. Managing your infrastructure, managing serverless application code, and managing containers. And so with containers, we're going to use the EC2 container service. And in particular, we're actually going to use Fargate, which is the ability to run containers without having to manage any infrastructure on AWS. And so these services are great. Lambda is amazing, Fargate's amazing, S3 obviously is amazing. The thing that's a challenge today for folks who want to stitch all these together is that there's quite a lot of work to really take advantage of these. The baseline amount of CloudFormation you have to write to use Lambda is a page of CloudFormation. To really use Fargate, you've got to write several pages of CloudFormation to set up all the right resources and things. And really then to stitch all these things together is even more complex. To hook up the event handler that makes sure that when something gets put in the bucket, it invokes this Lambda is some sort of somewhat arcane API calls. And similarly, how to launch a task from a Lambda. All these things are a little bit of work to do. And so one of the things we really want to make easy is for Pulumi developers to take advantage of all these great capabilities from these services, but do so in a much, much easier way. So in this example, what we're going to do is show off taking a video, and whenever a video gets dropped in a bucket, we will go and fire off a Lambda on new video, and that Lambda will launch a Fargate task. And this Fargate task will run FFmpeg inside a Linux container. an FFmpeg will extract a keyframe from the video and then write that into a JPEG. And the reason we're using both Lambda and Fargate here is because Lambda has a constrained amount of time that it can run and is a certain kind of sandbox where getting FFmpeg running inside that sandbox may not be as easy as writing an arbitrary Docker container. And so in this case, I can take advantage of the best of both, the fact that Lambda can be hooked up as an event handler for a bucket really easily, and the fact that Fargate lets me write an arbitrary Docker container and run it for as long as that job takes to do that keyframe extraction. And then finally, that Fargate task will write into a bucket, and that will fire another Lambda, which will just let me know that that JPEG file was written. And one thing I should note really quickly, we actually took inspiration from this from actually a really great blog post that was put out about how to use Fargate and Lambda together to build sort of a serverless application that took advantage of both containers and serverless capabilities. And one of the things, I mean, this blog post is great, and the example was sort of inspired by this. One of the things that was striking when we kind of looked at this example was just the amount of complexity there is in getting all this stuff set up manually, right? There's a lot of, in this example, it's kind of pointing and clicking around in the ECS console to set up Fargate and configure all the different pieces of Fargate. And this thing goes on for, like 30 pages or so of things I've got to kind of manually configure, and YAML I've got to write, and a variety of different things to go and use these. Where the actual example, if you looked at that diagram, feels like it should be a really simple application. And so our goal kind of with Pulumi is to really make these sorts of things as simple as you think they should be. And so let me show you kind of what that ends up looking like as a Pulumi program. So here's this code. It's about 40 lines of code in Pulumi, and I'll just walk through kind of some of the key things that are going on here and how we implemented what you saw in that diagram. So here we see this cloud.bucket, which is that bucket I'm going to use for both where I take in my videos and where I output the keyframes from those videos. And then there's a couple other things. There's a cloud.task. And cloud.task is just a container that I can run at any point in time that I want to. And I'm just going to describe what container that should be. And I'm going to describe some key characteristics of the container. So the first thing I'm going to describe is this memory reservation. So I want 128 megabytes here for this container. And then I'm going to describe build : and I'm going to point to a local folder on my disk. Let me just show what's in this folder. So this folder has a Docker file in it and a couple of bash scripts. And this Docker file is just a really simple thing. It's going to, just going to say no. This is using a base image that has a FFmpeg installed in it, and then it's going to run a couple of bash scripts. So this Docker file could be anything. This could be implemented in C# or in Rust or in Go or in whatever I would want. In this case, it's even simpler. It's just FFmpeg and a bash script. And so just really showing off that we can do anything we would want inside a Dockerized environment. And so I can create this sort of Docker container, and I can run it using this build : Now the interesting thing about this is when we say build : and then this file, what that actually means is we're gonna run a Docker build of that folder as part of the Pulumi deployment, and then we're going to allocate a registry inside AWS where we're going to push that build image to that registry, and then we're going to hook up that registry to this cloud.task so that whenever you ask to run that task, you're going to run an image from that registry. And so all of that machinery behind the scenes is a lot of what, if you looked at that blog post I linked to, about 2/3 of that blog post was just configuring all the different machinery you need in ECS and in Fargate to handle effectively what's done in this one line of your program here. And so we're really trying to take those patterns of how I manage the life cycle of this Docker image as part of my application and make that really simple, turn that into sort of one line of code you can use. Of course, you could still go and use the underlying primitives directly, but if you want to use it in this much simpler way, we give you some high-level building blocks for doing that. So let me just see what stack I'm on here. So Pulumi stack ls to see my stacks. I got this thumbnail or Twitch. It has 32 resources in it, so I guess I already deployed this. Let me just see what's in that right now. So you can see all of these resources are available here. Let me just go and look at that in Pulumi so we can sort of see what some of these resources are. So there's a couple of interesting things here. I mentioned that build : created a ECR registry, ECR repository. And so here you can see I actually have that repository hooked up. We can also see that we have a task definition for this task, so a ECS task definition. So all the underlying pieces that I might expect there. But let me keep going with this example and show you some of the other pieces we've got here. So after we create that task, then we want to actually hook up some event handlers. So here we're going to say bucket.onPut, and we're going to say when someone puts something into this bucket, I want to run this piece of code here. And again, this is a nice piece of code to just put right in line here because it's a really simple piece of code. All this is doing is extracting a few parameters out of the arguments, out of the data about that the bucket event, and sending those off to this task to run it. And so this is the kind of thing I really just want to stitch these things together. I don't want to create a whole nother Lambda and a whole nother file and manage that all separately. I just want to say I want to stitch my bucket and my ECS task together, and I can do that really simply. And we can, of course, provide the key suffix .mp4 to say only fire this on files which are of type mp4. Similarly, I can then go and say when I put a JPEG, so this is when that task completes, I want to see that as well. I'm just going to print out a message saying that I'm done. So when I deployed this, you'll see that it deployed a bucket name with this bucket here. And so I can go and say, let's see what's in that right now. So you'll see there's actually two files in here because I already ran this once. So at 10:54, I uploaded an MP4 file, and at 10:55, this cat.jpg got written. And so this was me testing this out earlier today. And so you can see, and I could do the same thing again, but I'll just leave it as is. But this shows off just, I can really simply go and build an app that takes that MP4 file, extracts the keyframe, and dumps it into a JPEG. The other interesting thing, just to build on what I showed in the last example, is here we can run Pulumi logs, and we'll see a couple of interesting things here. One, when I run Pulumi logs, there's actually 3 different sources that I can see. So I can see my onNew video, which was one of my little Lambda functions that ran when that S3 bucket was a new video was added. There's that onNew thumbnail when the process completed, and then there's the actual ECS task. But the key thing here is we're getting an aggregated log stream across all of those different components, all in one place. So as I'm developing this application, I can get the logs from each part of that and see those together. I could also go directly into the AWS console or to CloudWatch or whatever and see some of those examples as well. Okay, so I spent a lot of time today kind of showing off a variety of different levels of abstraction and some of the cool things you can do in terms of components. One thing I just want to quickly show off before I jump offline is a couple of the examples of using technologies other than AWS and JavaScript to work with Pulumi. And I won't go through the full life cycle of these. We can definitely do that in future Twitch sessions if folks are interested, but just to give you a sense of kind of what some of this looks like in other systems. So first off, for Azure, this is an example of creating a VM in Azure. So similar kind of thing to that first example I showed with creating a EC2 instance, but here we're using the Azure APIs. So this is the Azure Compute Virtual Machine API, creating a network interface and a public IP, all the different pieces of the core networking and infrastructure as service offering from Azure. And so we, again, have access to all the underlying capabilities of the Azure platform, and we can build the same kinds of abstractions and reusable libraries on top of Azure as well with Pulumi. We also have support for Kubernetes, and so let me just quickly open up so for folks who have done anything with Kubernetes, you've probably seen the Kubernetes guestbook example, which is sort of the hello world of Kubernetes. And I'll just show you really quickly kind of what that looks like in Pulumi as well. And so here we have a projection of Kubernetes into Pulumi. This exposes sort of all the core capabilities of Kubernetes. So here we can just say like new k8s.core.v1 And then we have all the different APIs that are available. And we actually automatically project this out of the Kubernetes metadata. And so here I can go and write, the same sort of thing I might write using YAML or JSON, but I can write it using JavaScript. And so I can pose these things together. I can build reusable abstractions on top of them however I want. And so this is, you can see an example of creating the full guestbook application. It's running Redis and running, so here's running Redis, it's running Nginx, running a variety of other containers and services, all in Kubernetes. And just as one final example to quickly highlight before we go, I want to show off just kind of what some of this looks like in Python. So if we want to use Python, very similar kind of experience. Here's that first web server example written in Python. It looks almost identical, except with sort of a natural kind of Python feel to it. So Pulumi takes all of those underlying resources and exposes them, as part of a language-neutral platform for composing and deploying applications. And then you can use those from currently JavaScript and Python, but we're going to expose those into other languages as well, so that folks can do that in other languages. So with that, let me just jump back to the homepage. So again, feel free, if you're not yet in the private beta, go to pulumi.com, sign up. We'll make sure to get you added to the beta soon. Once you get into the docs.pulumi.com site, you can get started just by downloading the Pulumi CLI, and then everything else will go from there. You can get started with sort of core containers, serverless, and infrastructure examples here. We have a great tour that walks you through all the core features of the Pulumi product and experience. And we're excited to come back and do some more of these in the future. So let us know what you'd like to see for next time. So with that, I'll finish up for now. And thanks everyone who joined. We'll talk to you later.